So early on, we saw that the line element squared comes from can be written in terms of the metric tensor, the differential line element, in this way, where we're summing on A and B, and from that we can well, it's recognized where this gets squared, but I can turn these objects into 2 vectors or 4 vectors by doing dxa with respect to some parameter, say maybe the proper time. Same for this one, dxb d tau. Now these are 4 vectors, and that's just the t tau, the whole thing squared. This is just a scalar. So this can be written as g. So there's a scalar here that is the result of 2 vectors. And so we're thinking of the generalized vector product, if you will. And the point is that this generalized vector product isn't a VB quantity. It's something that involves an interaction with the metric. So this object interacts with the metric, and then we can interact with VB. And so what we see is that where we're summing here, as we know, from this, right, GA, the 8th component, sorry, the bth component is G0 BV0 plus G1 BV1 and so on if we have 2 and 3. And so we can say that there are 4 components to this object, and that object is what we call VB, and then we have that which is the generalized dot product, and so that's just, we're summing on B, V0, V0 plus V1, V1, plus if we have 2 and 3, it looks like that. So, right, so this is, let's call this the generalized dot product of a vector with itself, and then the entire thing is the generalized dot product in space-time. Right, it's a vector with itself, but now we're in space-time, and so we have 4 components. So this would be the time component. And the point here is that we're generalizing this dot product, and normally we think of, say Cartesian coordinates, we think of this as being AX times AX plus AY plus AZ, where in fact the only reason why it looks like we're just multiplying components of vectors by themselves is because this quantity is 1, 0, 0, 0, 1, 0, 0, 0, 1 in Cartesian coordinates, and then the generalization of that, of course, has a -1 in the 0, 0th component if we're doing 0, 1, 2, and 3 for space-time. So the generalized dot product is between a vector or a 4-vector and an object that interacts with the metric. And we'll be dealing with these kinds of objects here. So this kind of a thing.